Okay, now let's talk about why null hypothesis and also the decision of reject the null or fail to reject the null. Okay, so why do we need a null hypothesis? Because there's no way we can directly test a research hypothesis. We cannot prove a theory. Okay, remember theory is different from law. Law is 100%, theory is not. Now, statistics is all about probability. So even if our results show the 100 miles difference between the two groups, there's still a chance it's just coincidence. For example, suppose our participants eat about 0.01 ounce of chocolate with a desirable man and 15 pounds with an undesirable man. That kind of hurts, right? Still, can be 100% sure our participants exactly represent all women population. Plus, how much difference is real difference? 0.001 pound is enough, or 10 pounds or 25 pounds. There's no absolute standard. Okay, so what we can do is we test the question. If null is true, then what is the probability to get the observed difference? So let me give you an example. Okay, we heard people say that eating fish will make us smart, right? Let's do an experiment on that, right? So we get a bunch of people, randomly divide them into two groups, experimental and control, right? So experimental, they eat fish for a year, and control eat whatever they want for a year. After a year, we measure their IQ scores and analyze the data. Suppose the average for experimental is 130, and for control is 70, right? Now, under the assumption that the null is true, that means these two samples are actually from the same population. Then what is the likelihood that we get extreme values, extreme samples like this, 130 versus 70? I would say it's really low, right? Because those are extreme values. Not a lot of people are from this area, right? Now, the probability is so low, we'll start to suspect the assumption, okay? So if the probability is low, then we reject the null hypothesis. That means we believe null is not true. Because these two values are so extreme, they are from the different populations, okay? Now, if we have that conclusion, we're very happy, for researchers, for prosecutors, because it seems to suggest that that a criminal is guilty. On the other hand, if the result for experimental is 103 and for control is 100, okay, so assuming null is true, they are actually from the same population, then what is the likelihood we get the result of 100 versus 103? I would say now it's quite a lot. The probability is quite high, right? Because yeah, indeed, most of the people are from this area. So we don't have enough evidence to suggest that they are from the two different populations. Now, if that is the case, so the probability is high, then we fail to reject the null hypothesis. And all the money and times are wasted because when we do research, we don't want the null hypothesis to be true. Okay. One thing to be careful though, even if we conclude that fail to reject the null, it doesn't mean null is true. Okay, not guilty doesn't necessarily mean innocent. It's just that we don't have enough evidence to suggest that they are from the two different populations. Okay.